Alright, the big video which we've been working towards. How to solve equations which have an algebraic fraction. So in this video I'm going to go over these 9 questions and how to do it. So quickly let's have a look at this. This one's pretty straightforwardish. You've just got one easy algebraic fraction where you just got like one term on the top over a number equals something. Then this one you've got a certain amount of x's minus, well, you can see it, right? Particularly notice the difference between these two. So this is when you've got 2x minus 1, all of that over 3 equaling 5. And then what's the difference if you're going to solve it with 2x over 3, all of that, so that's the fraction done. Take away 1 equals 5. Then we've got this, 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 we've got this. Right? You might want to pause it for a second, just have a look at them. Alright, let's take the shoulder row then. So, let's begin with this. And I want to, of course, it's not about learning the steps, it's about understanding this. Now look, we're trying to solve this, we're trying to find the x. So, I'm gonna, again, because whenever we're solving any of this, we're going to be working with scales. And remember, right now, this looks like this. Okay, now the aim for any question ever is to get x by itself. We don't really care what happens on the other side. If you want to think of it scales wise, this is what it looks like. Again, we don't care on that side. So let's just let's think about this. This is what we want by itself. You can see that's an x, and then I've covered a little bit about it. So you've got to think about it. Now, obviously we don't care about this side. We just want to do whatever we can to this side to go from x over 5 and finally end up at x. And here's the deal. Whatever we do on this side, we're just going to do the same on the other side. And who cares what comes out? That's going to be our answer anyway. So now, here's what you do. Firstly, understand this. This is saying x over 5. This is the same in a way of thinking about it as x divided by 5. Now, if you divide something by 5 and you want to undo it, are you guys happy that if you then times that whole thing by 5, you're going to come back to x? Now, a few people sometimes confuse this. They sometimes say, they think if you times it by 5, you get 5x. That's wrong. Think about this, and this will be clearer. If you're doing x over 5 times 5, firstly you're doing a fraction times a number. So you should never be thinking of it like that. So you put that over 1. Now look, these are the tops multiplying together, you get 5x. The bottom will become 5. Hopefully you guys can see that this can be written as 5 times x, 5 times 1. Cross those out, we're actually left with x over 1. Which is the same as x, alright? So yeah, we times both sides by 5 here. And when we times this side by 5, we're gonna get x. And obviously this side is gonna be 50. So our answer to the first one was x equals 50. And again, double check it. Look, 50 over 5 equals 10. And yes, 50 over 5 does equal 10. So that's the first thing. And now, there's actually a bigger general rule here. As you're going to see, we're going to see more and more fractions. But here's the deal: if you have any algebraic fraction where you're trying to find x, here's the deal: it's almost like that whole thing is trapped by being divided by 4. So, general rule. You're always going to divide by whatever's on the bottom just to get rid of this fraction. Alright, remember that. Whenever you see a fraction in algebra, when you're trying to solve an equation, you're going to have to times by the bottom. That's how you get rid of the bottom fraction, because it cancels out. Anyway, you'll see this more as I do more and more examples. So let's go over to the next one. I've got a big rubbing out to do on this bit. So give me a second. Let's move swiftly on. Okay, reasonably short and sweet. So let's go to the next one. So this one is 2x minus 1 over 3 equals 5. Now hopefully you guys are clear with this. So that's what it looks like. And again, I'm just going to put an X, like highlighting there. Now, here's what you do. The X is trapped up here, but it's all of this is being divided by 3. So look, general, this whole thing's being divided by 3. Let's times it by 3. That will free it up. And again, I'll do this maybe 1 or 2 times more, and then I'm going to assume you've got this. So if I times this by 3, you can see that's going to be 3 over 1. So you can see that then becomes 3 times 2x minus 1 on the top over 3 times 1. Look, chain of stuff multiplying. Yeah, you just get that. So just by whenever you times a fraction by its bottom, you're just left with the top. So if you can do that, hopefully you understand. You get 2x minus 1 here, and you get 45. So from this stage on, it's a really simple equation. We'll add 1 to each side. We get 2x equals 40, that should be 45, shouldn't it? Oh, yeah, we get 46. And finally we divide both sides by 2. And we get x equals 23. Right, so let's move on to the next question. Right, so question 3 now coming up. So question 3 is, alright, so notice this is a little bit different. So on the last one, you noticed we had 2x plus 1 over 3. Now this is different because only the 2x is being divided by 3. So let's see how we go about this. So let's think about this scales way. Remember, I know sometimes these scales don't look like they're balancing, but whenever I draw the scales, they're always balancing. Just have to excuse my sometimes bad drawings. Okay, so I'll tell you the way I recommend. I recommend not bothering with the fraction just yet. I say you take away 1 from each side. Taking away 1, you'll see straight away. I mean, it's going to cancel this one out. Plus 1, minus 1. So that cancels out. And you're just left with 2 here. So then you've got 2x over 3 equals 2. Then, if you can imagine, you've got that. The next thing I'll do, this is kind of like the last question. So this 2x is trapped by being divided by 3. This is when you times both sides by 3. So then you'll get to 2, well, then hopefully you can see that's going to give us 2x equals 6. And the answer is 3. Okay? We plug it back in. So 2 times 3 will be 6 over 3 plus 1. Well, 6 over 3 is 2, plus 1 is, of course, 3. So this is correct. Now, why I said to start off by taking away 1. And as you can see, that's a pretty easy thing to do. Easy enough anyway. Now, here's what I see quite a lot of people do constantly. So, let's kind of remake the equation as it was. They start off by saying, oh, let's times by 3. And again, there's nothing wrong with doing that as long as you do it right. But here's what they say. So they decide to times both sides by 3. And they end up going to here. They're like, all right, well, we times this by 3. And then they also times the other side by 3. Now, can you guys spot the mistake there? If not, let me explain. So remember, the reason I show you the scales thing is we can't do anything to this. We can't do it to any bit. We do it to the whole side, and we do it the exact same to the other side. So if you times this side by 3, then let's see what you do to this. Remember, we're timesing this whole side by 3. So this whole side, which we have to put in brackets, because that's the whole side, there's more than one term there, we're timesing that by 3. Now, if you're unsure how to do this, I'm pretty sure you wouldn't have any problems doing something like this. You know, you have to do that times that and that times that. Well, it's the exact same thing here. You're going to do that times that. Which, yeah, so 3 times 2x over 3, obviously once you put that over 1, you can hopefully see that that becomes 2x. So that's fine, I agree with this. But here's the problem, you forget that you've also got to times this 1 by 3. So that will give you 3, so that's where the mistake comes in. If you times this side by 3, don't forget to times this 3 as well. So one more time, this 1 as well. Sometimes, by the way, if I make little slip-ups like that, hopefully, well, let me know, maybe I'll change the video, but hopefully you get it. So look, from this point, we can still do it. So obviously we take away 3 from each side. It's 2x equals 6, x equals 3. But here's the deal. So I still think it's better to move that number to the other side. I think you ever see numbers on both sides, taking away one from the, one of them, we'll obviously join it up. So that's less of a problem. But here's the deal. If you did go about timesing by 3, hopefully you understand what, that you should also be timesing this because you're timesing the whole side. All right. So the next question. Bumping up in difficulty now. What is my number? Alright, so here we go. 2w minus 1 over 4 equals 2 minus w. So alright, so there's a few reasons why this one is much harder. And the first reason for this is, the simple fact is you've got more than one w. So let me just, write this so you guys can see. Oh, no, I didn't need to do all that stuff. Okay, so how to deal with this? Now, the best way to deal with this is to understand that, look, you've got 2 w's on each side. That's annoying because eventually, obviously in this question you want w, not x. We want to get w by itself, just one of them, and we've got 2 of them on each side. So, generally look from earlier, questions we've done. We know we really want to get it on the same side. So for example, when you've seen things like this, 3x plus 2, and even if you had like 2 minus 2w, you would add 2w to this side to make it disappear here. And when you add it to this side, these join up and make 5x. Oh, sorry, these should have been, that should have been w. This would have made 5w. Make sense? So that's what we've got to get to. But we've got a problem here because this w is trapped under this 4. So here's the deal. Let's first get rid of the fraction. Usually you want to try and get rid of the fractions as quick as possible. So let's get rid of it. We times this by 4. That means we've got to times this by 4. Remember, now if we times this whole side by 4, I'll show you this one last time. Then I'm going to assume you understand. Basically, look, if you've got a fraction divided by something and then you times the whole thing by whatever's on the bottom, you're just left with whatever's at the top. So I'll tell you right now, you're going to end up with 2w minus 1. Again, the reason being this. Okay, so this equals 4 times 2w1 over 4 times 1. Common denominator, get rid of that. You see? Now this side, hopefully see that's going to become 8 minus 4w. And now it is kind of somewhat straightforward. Plus 4w to this side, plus 4w to this side. So we get 6w minus 1 equals 8. Add 1, add 1. 6w equals 9. We've got to divide by 6, divide by 6. And then what we get? W equals 9 over 6. Obviously never leave always cancel your fraction down. Both of these can divide by 3. And you're left with 3 over 2. Just a common thing, a little point. Your answer doesn't have to be a whole number. So if it's not, just make sure you cancel down the fraction as well as possible. Of course, look, you can also substitute it in, but you can kind of see, fraction stuff is annoying. So you're not going to, always substitute it back in, especially when it's a fraction, because it might take too long. And especially if you're in an exam, unless you've got loads of time at the end and you want to double check, make sure you know this maths right. and leave the double checking to last. But hopefully that will make sense as well. So alright, so let's get to the next question now. Where are we? We are at number 5. Okay. This one should be okay for you guys now. Okay. So, again, plenty of things annoying here. Plenty of things annoying. One of the first annoying things being we have 2 x's. Always annoying when you want to solve, because we've got to get it by itself on one side. And this is stuck on top. So again, listen, usually when unsure and there's a fraction, just times both sides by what's on the bottom. So let's times this by 3. Now hopefully now, I'm not going to keep going over this, this will give you x, 18x plus 5. Now we times this side by 3, and that's going to equal 30 minus 3x. And look, now it's a pretty simple equation after that. So let's add 3x to each side. Right, we got 21x plus 5 equals 30. Take away 5, take away 5. So you've got 21x equals 25. Now we're just going to divide by 21, and we'll get to x equals 25 over 21. That's it. Can't really do much better than that, unfortunately. I haven't made a mistake, have I? No, I haven't made a mistake. Okay. And now, by the way, this was an exam question. This was an exam question in the AQA paper. I can't remember what year. It was a 4-marker. And that's it. That's the right answer. So, again, hopefully, as you're seeing the difficulty bump up, it's, you're getting it. So, okay, now let's go to something a little bit more interesting. So this has got 2 algebraic fractions. So we got y plus 1 over 3 plus y take away 2 over 2 equals 2. Now, again, we'll draw the scales for you. Okay, so here's what you have to do. A few annoying things. Can you see there's 2 y's? They're both on top of fractions, all of this. So if you've got more than one fraction involved, like there is here, here's what I recommend you do. Join it to make 1. I want you to join that to make 1. We're going to rewrite this bit. So let's just focus on that. So we've got y plus 1, and hopefully you've seen that video now. So let's not do that. Oops, I need to move this now. Yep. So yeah, what are we going to do? So we've got fraction, add a fraction. So let's join it up. And look, we're going to first have to get the common denominator. By the way, if you don't know what I'm doing, you need to watch the rewrite video on how to join 2 fractions by adding and subtracting. Right? Because if any step I do here doesn't make sense to you, it's because you need to watch that video. Okay? Does that make sense? I've got a common denominator. I've times this one by 2, all of it, all of this. Now I just add the tops together. So I've got 5y minus 4. So do you see now, look, so if I rub this whole thing out, I can literally now change this whole bit. And here's what I change it to. Change it to 5y minus 4 over 6 equals to a much easier one. So basically, look, I've rewritten that whole bit. So, do you see how much easier it is now? I've got myself in a pretty nice position, actually. And this should now look like the easier questions. You see, it's usually just like one extra trick or something which makes life way easier. And now look, there's our y, it's trapped into a fraction. We're going to times this by 6. We're going to get 5y minus 4, and we're going to get 12. So let's carry on. 5y minus 4 equals 12. We'll add 4. We get 5y equals 16. Then we're going to divide by 5, so we get 16 over 5. There you go. And okay, so let's move on. Right, so I think we're at number 7. Are we at number 7? We're at number 7. Okay, and this is going to be literally the same as the other one. There is that negative. So if you watch that rewrite video where you join two fractions into one fraction when they're taken away, then this should actually be a very straightforward video for you. And oh, by the way, pause these things. Pause it after I, write anything. Try it yourself and then play this again. But anyway, let's go for this. So look, we've got two fractions. We're going to join these two. We're going to join these two. So here's what I'm going to do. I need a common denominator. That's going to be 4. So I'm just going to be timesing this one by 2. I don't need to bother with this. So let's see what that becomes. So I've still got this one exactly the same. Minus 6x minus 6 over 4. Excellent. So now I have to be careful with this. Do you remember when we take away, we're taking away all of this minus all of this when we join these together. So you've got to be careful here. So it's 2x plus 3 minus 6x minus 6. Remember, this is all rewrite straight still. Okay, and this now becomes 2x plus 3 minus 6 plus 6. Again, if you don't understand that, watch the rewrite videos. Okay, let's clean the top up. So we've got minus 4x plus 9 over 4 equals 2. You'll notice these negatives, things getting ugly. Don't be scared of that. As long as you know what you're doing and what you're doing makes sense, keep going. And again, these ones I'm giving you, these are all exam questions, so you've got to get comfy. Now look, here's our x, which we're bothered about, and it's stuck under a 4. So look, we're going to be now timesing both sides by 4. So we're going to get 4x plus 9 equals 8. Oh, and it's pretty straightforward after that. So minus 9 from each side. Minus 4x equals minus 1. Now we're going to divide by minus 4 on both sides. That cancels. So we're at x equals minus 1 over minus 4. Now, here's one thing I want you guys to know. If you've got two negatives on top, you can just get rid of them. And here's the reason why. Now, we're going to times this fraction by 1. But we're going to write 1 in a very special way. We're going to write it as minus 1 times minus 1. Or you can actually think of it just times top and bottom by minus 1. Yeah, whatever. So times top and bottom by minus 1 times minus 1, which is times by 1, so we're not changing it. Minus 1 times minus 1 is 1. Minus 4 times minus 1 is 4. So x here is a quarter. Hopefully this is making sense to everyone. Alright, so now we have a rearrange to make x the subject question. Remember, this rearranging questions are exactly the same as solving, except your answer isn't going to be a number. So let's write this down. So they give you y equals 3x minus 2 over x plus 1. And remember, rearrange to make x subject. Okay, so this is actually quite a nice jump up. So we need to think about this a little bit harder. So here we go, here's our balance. So we've got y here. So okay, few annoying things. We've got two x's, but here's the deal. And they're on the top and bottom of a fraction. Now we haven't really run across it at the bottom of a fraction. Now, the same rule is going to apply. If you have a fraction which has x or whatever you're trying to solve for, then guess what? You just do yourself a favor, just get rid of that fraction. And the way you always do that is just times both sides by that bottom. So we go, we're going to be, and the whole bottom, that's what I'm putting in a fraction. Sorry, in brackets. Okay, so imagine what we do there. Now hopefully you guys are happy that this will just become 3x minus 2. And this will become yx plus 1, which will multiply out to give us xy or yx, doesn't matter what order you do it. And that's going to be equal. So that's really the big step. And you're seeing these rules. So basically, see a fraction, multiply top and bottom. Sorry, no, multiply both sides by the bottom. You see this. So now we're at xy plus y equals 3x minus 2. Now hopefully you guys, this is now somewhat straightforward. Remember that thing, just move everything which has the x onto one side and move everything that doesn't onto the other side. Because here's the deal, we're trying to get x on one side, so anything that doesn't contain, any term that doesn't contain x, you might as well move it to the side we don't care about. And then, you'll see in a second, we factorize, but, you know, we start off like that. So let's write this, so, you know, I'm going to start off by, well, let me just write this first. Okay, so I want this term here, and I want to bring this one over there as well. But first, let me get rid of this y. Okay, so that's going to give me xy equals 3x minus 2 minus y. That's an x term, that's a number term, that's a y term. Nothing's going to cancel out. So let me just update that. Okay, so that's where we're at. Okay, now the next thing, I'm going to, it's all done now as well. I'm going to take away 3x to bring it over. Oh, I hate saying that, but you know what I mean, right? So get rid of it here and bring it here. So this is now going to change it. Let me clean this up. This looks like a mess. So I've taken away 3x from both sides now. Oops. There you go. So that's where we're at now. We're at xy minus 3x equals minus 2 minus y. Now what we're going to do, we're going to factorize. So what we do, we rewrite this bit, we take the x out. Remember, this is the beauty of factorization. If you have two things which have an x in and one of them's like y or something like that, factorizing, we've gone from two x's to just one. Yeah? Minus 2 minus y. And now, obviously, because that's this side, so let me rewrite that side. I'm going to not bother with the colors now. Okay, looks like I am. Remember, that this literally means x times y minus 3. So this is essentially x is being x, the thing we want. It's being multiplied by y minus 3. So to sort that out, we're going to divide it by y minus 3. Okay, that's going to get rid of that. And we get to this point. We get to x equals minus 2 minus y over y minus 3. Okay, so that's it sorted. Now, just out of interest, just like a little thing, you know, basically, can you see that in reality it's this? In a fraction, there is a way to switch every single sign. So, but I'll tell you in a second how you do that. But can you see how it'd look nicer if it was written like this? Let me switch that around. Yeah, not that I'm not sure if you get any extra marks for that, but you know, still worth doing. Just make it look pretty. It's not the biggest deal. This is correct, by the way. This is correct. Obviously, you don't need a plus there. That's correct. But yeah, the way you do that is, again, you times top and bottom by minus 1. And you can almost imagine that. So minus 1, minus 2, minus y, times minus 1, y minus 3. And hopefully you can see minus 1 times minus 2 is plus 2. Minus 1 times minus y is plus y. Minus 1 times y, plus y is minus y, and minus 1 times minus 2. You get that. Okay, just finally finish this off. Okay, so yeah, but this is the point where the hard work's done, really. This is where you've actually got the answer. This is just writing it in a different way. It's really just kind of like, you know how you sometimes write 5 plus x. It's the exact same thing as x plus 5. That's the deal, but, you know, they like this. You know what, I might find out if there's any point doing it, but yeah, for the time being, hopefully that makes sense. So anyway, and now we come on to our hardest one. So one where you have two fractions on the same side, but the bottoms have the x's and stuff. So let me first find it. Right, so this is what it looks like. 5 over x plus 2 plus 4x plus 1 equals 2. Now again, we're going to go with the same thinking. We're going to make this, we're going to rewrite this as one thing. And to do that, you multiply this fraction by this denominator. So this one by the whole of x plus 1. This one by the whole of x plus 2. Again, this one by x plus 2 as well. This one by x plus 1. Okay. Now watch what that becomes. This one becomes 5 over. And here's the thing, don't bother multiplying these out unless you need to. You can actually give your answer like that. You just can't, take my word for it. If you multiply out, there's nothing wrong. A general rule, don't. Not that it matters in this question, to be honest. But a lot of times you end up kind of cancelling and stuff. So just take my word for it. I'm blabbering a little bit. So, okay, you get to this stage. So now you've got a common denominator. Now add the tops. Because it's a plus, this is generally easy. We can multiply this out, by the way, if we want. This would be 5x plus 5. This would be 4x plus 8. So then, if you add these together, hopefully I can skip a step with you guys. 9x plus 13 over x plus 2. X plus 1 equals 2. Now, here's the deal. We've got this whole fraction. We're going to have to do the same thing we're always doing. Whenever you've got a fraction with x's in, divide, times both sides by the bottom. So we're going to literally times both sides by this little 2 bracket mess. Yeah, this is the highest level. This is A star level stuff. This is grade 9 stuff. And you'll get to this stage. Now, we're going to start multiplying this out. So let's start by just first multiplying these two things together. The reason why, by the way, we can just multiply this, let's have a look at that. This means 2 times x plus 2 times x plus 1. Right, so 3 things multiplying. Now, the reason it doesn't matter what order you do them in is think about 2 times 3 times 4. Now, hopefully you guys know that's 24. 2 times 3 is 6, times 4 is 24. But here's the thing. With this, we could either do that first and turn this into 6 times 4, which obviously gives us 24, or we could have just as easily done this first and done 12 times 2. That would have given us 24. We could have actually even done 2 times 4 first, got 8, and times it by the other one, 3. So the order we multiply stuff literally makes no difference. So I'm, just for the sake of it, I'm going to start off by multiplying that. So, hopefully you guys know 2 like that is just literally 2x plus 4. Okay? But listen, we're still multiplying this whole thing by that. So make sure you keep that in a bracket. Because if you didn't, then you just say this. And that's dumb. At no point was this going to just end up multiplying just that 4 at the end. It's going to obviously multiply this whole thing. Hope that makes sense. Otherwise, ask me in person. And then now we multiply this stuff out. So okay, so I'll skip a few steps. I'll assume you know this. Plus 2x plus 4x plus 4 is 9x plus 13 equals plus 6x plus 4. Okay? So now we're going to try join. So do you see we've got an x term here? So this is an x term. This is a number term. This is an x squared term. This is the x term, and that's a number term. So here we go. So let's kind of get everything to one side. So we'll take away 9x from both sides for this. So hopefully you see we're going to get 2x squared. Now imagine kind of putting so that'll kind of go away from this side and we'll get a 9x here. Hopefully you see plus 6x minus 9x is going to give us minus 3x. So, and then we're going to also take away this 13 from this side. Imagine we're having that 13, so we've got plus 4 minus 13. That gives us a minus 9. So actually, we end up at this point. Let me put this in red as well. I want to really make a point of this. So we've got to this stage. Now, that's a funny one, isn't it? So this one's saying, so to find the answer which makes this whole thing work, we're looking for a number. If we square it and multiply by 2, then take away 3 lots of that number, take away 9 equals 0. Now do you notice this? Basically, we've got a certain number of x squareds, then we've got a certain number of x's. Oops, I'm going to do that. X's. And then just here, we've just got a certain number. Okay? Well, listen. This is a quadratic. This thing here, when you have a certain amount of x squareds, x's, and a few some number, that's a quadratic. And the fact that it's equaling something, this whole thing is, well, that's the quadratic, by the way. This whole thing is a quadratic equation. And now this, so the section for algebraic fractions is now over. And the next section we're going to go to is actually literally figuring out how the hell would we solve these quadratic equations. So, quick thing, I'll give you a few examples before you leave. This is a quadratic equation. Whoops, that should be squared plus 13x minus 5 equals 0. This is a quadratic equation. 3x squared minus 7x plus 15 equals 0. So basically, and I can just do it. It's basically a certain amount of x squareds, x's, and a number. So that's the next section. It's a nice little kind of tie-in, don't you reckon, from this algebraic fractions thing, taking over the quadratics. So there you go. Isn't it almost pretty the way maths works sometimes? So okay guys, well done for completing the algebraic fraction section. Assuming you did actually complete the whole thing. Obviously I'm not watching you. And yeah, let's take it to quadratics. I don't know, take a break, put your feet up or something. But yeah, alright, so see you in the next section.